Here back at AP Review. This is 2016 AB BC Free Response 5. The inside of a funnel of height 10 inches has circular cross sections as shown in this figure, or better on the actual AP figure because I shouldn't be in charge of drawing things. At height h, the radius of the funnel is given by r equals 1/20th times the quantity 3 plus h squared, where h is inclusively between 0 and 10. The units of r and h are in inches. Part A, find the average value of the radius of the funnel. Okay, so this involves us knowing the formula for average value of anything, right? So the average value of a function, right, is to integrate the function over the interval and divide by the width of the interval. So 1 over 10 minus 0 would be dividing by the width of the interval. And we're going to integrate from 0 to 10 of my radius, which is this 1/20th 3 plus h squared dh, right? Cool, so you want to make sure you set that up. If I were you, I'd factor out the 1/20th to go with the 1/10 in the front. So I'm going to make this a 1/200th, the integral from 0 to 10 of 3 plus h squared dh, right, which is going to be a 1/200th in front of a 3h plus h cubed over 3 from 0 to 10, right? So that's a 1/200th of, when I plug in 10, I'm going to get 30 plus a 1,000 over 3. And then when I plug in 0, it's going to be a bunch of zeros, right? 0 plus 0, which doesn't always happen, but frequently happens with polynomials. Cool. So it's up to you how you clean this guy up, right? I would argue it's probably easiest to get a common denominator of 3 here, right? So if you times this guy by 3 over 3, you're going to get a 1090, right? So you're going to get a 1 over 200 times a 1090 over 3, right? So I'm pretty sure you get 1090 over 600, and it's fine if you want to leave it that way, but it would also totally be logical to cancel a 0 because they both have zeros at the end, right? So I'm going to get 109 divided by 60 inches, right? Because it's the average value of the radius, and the radius is measured in inches, right? Part B, find the volume of the funnel. Okay, so the volume of the funnel is going to be something we get from adding up every little cross section, right? So it's sort of like the volume of a cylinder, right? A cylinder is like a stack of CDs. Not that any of you probably still listen to CDs anymore, but you'd find the area of one CD and then you'd times by the number of CDs, right? And that's the idea. So so when I want to find the volume of this thing, I'm going to find the area of one of the little circular cross sections, right? So the area of one of these cross sections is pi r squared, right? Which is pi times this crazy thing, whole quantity squared, right? And then my volume is going to be if I integrate that from 0 to 10, right? So my volume is going to be the integral from 0 to 10. I'm going to put the pi out in front of this, and it's up to you. I'm going to go ahead and make this a 1 over 400 because I'm going to square the 1/20th. And then this 3 plus h squared quantity squared, which I'm going to have to FOIL, right? So this is going to have to be FOILed. Foiled. Come on, brain. Okay, so I would probably yank the 1 over 400 out with the pi, right? So pi over 400. When I FOIL this out, and it's up to you where you show the work for that because, you know, maybe you don't need work. When I FOIL out 3 plus h squared times a 3 plus h squared, right, my first is going to be a 9. Outer and inner will both be a 3h squared, so that's a 6h squared. And last will be an h to the 4th. It's up to you if you want to reorder this and put this in more standard form where the h to the 4th is at the front. I don't care. And you're integrating this, right? So I'm just going to go ahead now that I FOILed it and integrate it. So I know that's going to be a 9h, right? Plus a 2h cubed plus an h to the 5th over 5 from 0 to 10. The only saving grace in this problem is that at least we're plugging in tens, which are like the nicest things that you can possibly have to plug in if you have no calculator and big numbers. So, well, 10 and 0. So it can't get a lot nicer than them giving me a 0 as one of these bounds that cancel, and then, hey, at least if I have to put something to the 5th, it's a 10. So I get a pi over 400. So when I plug in 10, this is going to be 90 plus 2,000, right? Because it's 2 times a 10 cubed, right? Plus, so 10 to the 5th means put 5 zeros. 1, 2, 3, 4, 5, right? Just like 10 to the 3rd meant 3 zeros, all over 5. And you'll probably want to clean that up a little, but it's up to you. So this is not super awesome and fun. It's going to depend on sort of your preference about how you deal with this. I'm going to argue that this guy divides by 5 pretty easily, right? The easiest way to deal with this, if you're kind of overwhelmed by this at all, is to treat this as a 10, right? So this is 100,000, right? So this is a 10 times a 10,000. So you could just make that 10 over 5. Like you can make that a 2. So basically you get 20,000, right? So what's going to happen is you get that this is a pi over 400. And then in here you get a 90 plus a 2,000 plus a 20,000. Right? So if we kind of come up here, and I get that you're probably not loving this. You're like, oh, that's super fun. So that's a 22,090. Sorry, threw in an extra 0 there. All over a 400, and oh hey, it's got a pi, right? So I'd probably cancel a 0 out of that and get 2209 pi over 40. Because it's a volume, it should be inches cubed in this problem. And let's double check that I'm right and didn't do anything too stupid. Hey, look, I didn't. It's awesome. Okay, cool. So part C. The funnel contains liquid that is draining from the bottom. At the instant when the height, oh, suddenly it's turned into related rates. At the instant when the height of the liquid is 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. At this instant, what is the rate of change of the height? So it's related rates, which I get instantly gets, no pun intended, everybody's heart rate up and like you're panicking and you feel like you're having a horrible anxiety attack. But here's what we know, okay? So we know that when we do related rates, we're usually using DREDS, right? So diagram and rates, oh look, they mostly gave that to us. We'll list the stuff we don't know. Equation, they definitely gave to me, right? It's a 1/20th. I'm probably going to distribute, I mean, you don't have to, it's up to you. I would probably just make this a 1/20th times 3 plus a 1/20th times that h squared, but it's up to you. I'm going to have to derive that thing with respect to time, and then I'm going to have to substitute stuff in. So they already gave me the diagram. Let's talk about what stuff they told us that we know in part C, right? In part C, they told us at the moment when h equals 3, dr dt, right? When h is 3, dr dt, the radius is decreasing at at a fifth of an inch per second. So negative 1/5 is my dr dt. I can also use this to find r, right? Because I know what r is in terms of h. So at that moment when h is 3, I know that r is 1/20th of a 3 plus an h squared, which would be a 3 plus a 9, right? So that would be a 12. So I know that r is, and you can leave it as 12 over 20, right? That's absolutely fine if you don't want to risk doing something silly. You can either leave it as 12 over 20, right? Or you could cancel a 4 and make this a 3/5. That's fine. Okay, so now I know those values. If I derive this guy, right? The derivative of r is dr dt because I'm deriving with respect to time. The derivative, sorry, it's not a plus, it's an equal, mea culpa. Derivative of this coefficient, which is of this constant, which is a 3/20th, is 0, so it's gone, great. And the derivative of the 1/20th h squared becomes a 2/20th h to the first dh dt. Well, this is the thing they want. They want dh dt. Oh, hey, I didn't even have to find r. Look at that. Turns out I didn't need it. My bad. So when I go to substitute in, dr dt is a negative 1/5, right? It equals a 1/10 times my h, which is 3, times dh dt. It's fairly simple to solve for dh dt, right? So I'm going to go ahead and either multiply by 10/3, right? Or multiply the 10 over first and divide by 3. It doesn't matter. So I get negative 1/5 times this 10/3 equals dh dt. So I get a negative, the 10 and the 5 cancel, I get a negative 2/3, and h is measured in inches in this problem, and time, I believe, was in seconds. Yep. So there's my answer. That's my dh dt. Okay, and I didn't actually end up needing r despite doing the work to find it. Cool beans?